Yeah, so I'm Dan Beller, Director of Cloud Solutions. Just a little bit of background on myself for 30 seconds. I spent the last 20 or so years doing government contracting, mainly DoD and IC. Pretty much done every kind of role except for official PM and application developer. So I've done cloud systems architecture, engineering, customer liaison, team lead, field support. I've racked lots of servers, run lots of wires, done a little business development. The last 5 or so years, I've spent working on large scale cloud deployments built around high performance or near real time mission processing, and that's actually continuing here. All right, so first couple of slides are just some level setting. So, what is cloud computing? Dictionary definition: on demand delivery of IT resources, typically using a cloud consumption cost model. What that really means is that you pay as you go for the most part. There's lots of stuff we can get into here, but at a real high fire hose, there's some different flavors of clouds. So we've got public commercial clouds, your AWS, Azure, GCP. You've got private clouds such as OpenStack, and then you've got I haven't really found like an industry accepted term, but basically government or regulated clouds. So think of ones that meet ITAR or EAR restrictions. You know, your AWS Gov clouds, your Azure Gov, basically all the things that Jeff is busy trying to enable purchasing through JWCC and AT-AT. So one note is that on these government clouds, and they're more likely that we're going to run into those across classification domains, even though they say, oh yeah, it's all the same. There are often subtle differences that can really mess you up if you're not planning for them. So just the implementation of some things might be a little bit different, but more importantly, the services that are in scope can vary drastically. So if you go and you build a solution based on, what's available in commercial AWS, don't expect it to just work in C2S. That would be the main takeaway I'd have on that point. There are different, they call it a shared security model. So it's effectively what you're responsible for. So at the bottom level that you'd be the most responsible for be infrastructure as service. So think in terms of VMs, user-defined networking, things like that. Then you go up a level to platform as a service. So think about like a managed Kubernetes, and then at the top you've got like software as a service. So think Salesforce or Replicon. Your responsibility as you go up that stack for security is smaller and smaller. So a lot of the time when we're building a custom solution for the government, we're probably focusing more at like the PaaS level, because that's probably the easiest model to work with containers or Kubernetes, which honestly, we could have a number of brown bags just on Kubernetes and its nuances, but that's not today's topic. How do we deliver these solutions into the cloud? Infrastructure as code, IAC. So back in the old days of 10 years ago, you'd be talking about deploying things either bare metal or VMs or some sort of cloudy thing that either would be a lot of a ClickOps or manual or a human initiated installer or script. Gets pretty error prone. Humans are kind of the enemy in a lot of this, just from a complexity standpoint. Lots of issues with, I installed my OS, it works fine in the lab, and then I go to the hardened OS that I'm not allowed to have outside of DISA or somebody else, and now it doesn't work, and you spend months just fighting to get things working. We're effectively, since we own more of the stack through either IaaS or through PaaS, we're able to test and design our systems using within our target environment a lot easier. So we get into tools. So basically all of these IAC tools, the goal is to allow for scalable automated delivery of the cloud configurations. So deploying our networking, deploying our Kubernetes or our VMs, installing our software on them. So you get into a lot of the heavy hitters, your Terraforms, your Ansibles, AWS, CDK, a couple others. They kind of come in a few different flavors across a couple of different pieces, but basically you've got cloud-specific ones. So for instance, AWS Cloud Development Kit or Azure Blueprint, that's obviously going to be tailored for those cloud environments. And then you have ones that support multiple cloud platforms such as Terraform or Ansible, Puppet. We also talk about imperative versus declarative tools. So imperative would be more like a script. And we also introduced this idea of idempotency, which means I'm only going to change something if it needs changing. So imperative tools of they're not as popular nowadays in favor of declarative tools. Imperative tools have the challenge that if you're starting from a different starting point and that you run through it, since it is more script like, you may end up in a different endpoint than you intended. Whereas declarative tools, their goal is that regardless of your starting point, you end up in that same intended configuration. Again, something we can talk about more, but we typically would then add a layer, an orchestration layer on top to create pipelines that could be kicked off based on code updates or cron jobs or things like that. So think of GitLab or things like that. It just in the platform engineering, so much of it just layers on top of each other. So I'm going to talk a little bit about one of the projects that we're working on here. So a common DoD use case is to develop software unclassified and then deploy it onto higher classification environments. Really common, because a lot of the time what we're doing isn't that sensitive. It's just that the data that is being processed is. So what that means is that in addition to the typical challenges of automating a complicated set of tools and deploying services, we also have to be able to handle it under change management control. We have to package it. We have to version it. We have to transfer it. We have to transfer its dependencies. There's just a lot of moving parts that if you effectively don't have the internet or you're air gapped, makes it a lot more complicated. And that's often something that gets overlooked. Our problem statement is effectively, we need to deploy this complicated network security and processing stack repeatedly. It's way too complicated to do it manually or using low-level deployment stacks like CloudFormation or ARM. In this particular project, there was also a lot of uncertainty as to whether or not we were going to be deploying into AWS or into Azure. Ultimately, we ended up in Azure, but that meant that early on we decided to make a choice of using an IAC tool that supports multiple clouds for flexibility. So ultimately, we chose Terraform, this little thing called TerraGrunt that I'll talk about in a minute. The entire program is PaaS only. We have no VMs. We don't want VMs. VMs are a real pain because you've got to STIG them. You've got to update them. Much better to let the cloud providers manage a lot of those things. So just to give you an idea, we're deploying into 2 different Azure government clouds. The whole solution is built around Kubernetes and micro-ish services, I'd say, in OCI/Docker containers. And ultimately, we have 6 multi-region environments, each with 3 Kubernetes clusters. And we have it configured with the security baked in. So customer managed keys for isolation. Azure has a DoD Impact Level 5 isolation guidelines that you have to follow to go above and beyond just push the button. Overall, biggest challenge with any of these kind of complicated IAC deployments, environment variables, things that look like environment variables but maybe aren't, and not repeating yourself. So the dry principle. If you're not careful about it, you'll very quickly find yourself needing to define hundreds of environment variables that all look kind of similar for every environment you're deploying into. So redundancy is bad. Opportunities for human error. This is one of the bigger areas that all of this automation allows a human to go and mess things up. So just a little best practice for those environment-specific variables. Aggressively try to use relevant cloud APIs to do lookups first. If you're able to, like for instance, in AWS, if you wanted to, find out the ARN for some specific resource, use a lookup. Get the UUID back or get the ARN back. Static environment variables are you're just asking for trouble, and it's not easy, but the attempt is worth it. There is some genericized Terraform code. All right, and now let's get into very quickly what does Terraform provide for you. So like I mentioned, it supports multiple cloud platforms. It's declarative. If it's not the market leader, it's definitely very popular. Within industry, within DoD, it's in a lot of ways kind of, I think, the default right now. Has a robust set of plugins, so you can integrate with any cloud provider that you're likely to run into, as well as Kubernetes providers. And effectively, since it's declarative, you would effectively just state what your resources are and let Terraform figure out what you have versus what you want. It's all very modular, built around this concept of a single root module that then calls a number of child modules. The downside that we pretty rapidly ran into is that it doesn't scale to multiple environments without a lot of variable repetition. Enter TerraGrunt. the whole reason for TerraGrunt and the reason that we brought it into the project is it allows you to scale out and keep your sanity, as I would say. So we can centralize variables for an entire deployment. We can have multi-phased deployments. So I can, for a given environment, I can have my network stack get deployed, and then I can have my platform baseline get deployed, and then I can install my software, and I can manage them separately, or I can manage them as distinct phases rather. And TerraGrunt actually lets you call them and you can order them, and it effectively takes that next step so that you can have multiple routes and and multiple environments and still manage it all in a relatively small amount of files. It also allows you to do plugin management, versioning, and things like that in a consistent way, because you can just set those things globally, tell TerraGrunt this is what you use for everything, and kind of go from there. Okay, so now we get to the fun part. I wrote some sample code. It's very simplistic, but gives you a flavor of what you can do with Terraform and TerraGrunt, and maybe it could have some benefits for some of our additional work that we have going on. So, problem statement: I want to always have Azure AD groups with associated roles, but I want each environment to be a little bit different. All right, give me a second. I'm going to switch over to VS Code. All right, so effectively the file structure I've got, I'm going to start by talking about the roots, but everything is effectively, there are three main entry points. So I have exactly one root module here. It's pretty simple. So I've mentioned providers a few times. The versions are all going to be globally managed, but if you need to enable or customize any features, those would get configured at the beginning of your roots Terraform file. And then you would call, 1 to n modules here, which are those child modules that I referenced. I'm not going to dwell on it here, but we also have some variable definition. So effectively, this defines the group's role definition, just from a variable type. And then there's a default set. That default set is important. So this calls the AD groups, which I've got defined over here, and same idea. We've got more variables defined or declared here, but what this does is it's going to do a couple of those dynamic lookups that I referenced earlier, effectively to get the name of the subscription and I believe it's the subscription ID. No, the owner. So these are dynamic, so that makes the code more portable. It can run in any Azure environment. And what it's going to do is it's going to create a group, and then for each role that's associated with that group, it's going to associate it or assign it. So pretty simple stuff. Then we add the next layer, which is the TerraGrunt portion. So let me open up what I've got here. Basically, I've got two environments defined. When I say environment, in this case, I mainly mean different subscriptions within Azure, but it could be, you could define it in a lot of different ways. It could be different regions, it could be different virtual networks, VPCs, what have you. It's effectively, what am I trying to pivot on and what am I trying to reuse? So in this case, I've got environment A and environment B, not the most exciting names, but you can see kind of the breadcrumbs. So TerraGrunt, it defines what root module in Terraform am I running. And in this case, it also says these are the providers. So that's just going to have the versions that I'm going to be using primarily in a format that TerraGrunt can interpret. Since I didn't define any variables, it's going to use the defaults that are set in the root. So ultimately, I would get a cloud admin, app admin, auditor, and ops monitor with those associated roles. On the right, I've got environment B. The first 7 lines are identical. The only difference is that I am now overriding that group definition. For this example, I have concluded I don't need an auditor group. I've overridden that and defined it here. Now, I don't actually have an Azure cloud to deploy into for this demo, but the way that it would work, there's a Vagrant file in here that pre-installs all the tools that are used here too. That's available in GitLab. But effectively, what you do is, in order to change the context of where you are within TerraGrunt, so which environment, you would run TerraGrunt in environment A. And if you want to switch, you would then run it in environment B. So it's not the most exciting, but it's it's pretty easy to context shift and effectively have that ability to scale out fairly robustly here. So to conclude, IAC is good. Terraform's declarative, useful, and popular. And TerraGrunt lets you scale out Terraform while still adhering to the dry principle and keeping your sanity.